Hello everyone. Today we are going to show you some experiment on Bernoulli's principle. Before that, we want to know what is that Bernoulli's principle. In fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in fluid's potential energy. This principle is named after Daniel Bernoulli, a Swiss mathematician who published it in 1738 in his book Hydrodynamics. And the formula for Bernoulli's principle is that P1 plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho GH2. What is that rho? Rho is the fluid density. G is the acceleration due to gravity. P1 pressure at elevation 1. V1 is velocity at elevation 1. H1 height of elevation 1. Pressure at elevation 2. V2 velocity at elevation 2 and H2 height at elevation 2. Now again I am explaining what is that Bernoulli's principle. Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. Now, I will give you some demonstration of Bernoulli's principle. Here you see we have taken two balloons, and if we blow air in between, what happens? Let us see, and I will explain what is happening here. Let us blow air between the two balloons. Let's see what happens. Whenever we blow air in between these two balloons, the two balloons collide. The reason is why the two balloons are collide, that explains Bernoulli's principle. Not only this example, I will give you some other examples also to show that how Bernoulli's principle works. Here you see when we blow air here, what happens? When the speed of air is more, there is a decrease in the pressure in between these two balloons. And when there is a decrease in pressure, you see the pressure at this point and this point is more. And we know that pressure flows from higher pressure to low pressure. That means this higher pressure makes these balloons collide each other. And in this way, Bernoulli's principle is working. Let us again try to blow between the two balloons, and let's see what happens once again. You see, the two balloons collide with each other. The reason is that whenever we blow air here in between the two balloons, the high speed of air causes a decrease in the pressure in this region. Not only that, when there is a decrease in pressure in this region and the pressure at this point is more than this region, the two balloons collide each other. Because we know that pressure flows from higher pressure to lower pressure, or the wind blows from higher pressure to lower pressure. That's why these balloons comes together and collide with each other, and that is what we call it as Bernoulli's principle. Now I will give you some other examples also to show how Bernoulli's principle works. Suppose I have taken a paper, and let's see what happens to it. See here, this is a paper. If we blow air on this side, let's see what happens. Let's see what happens if I blow air on the upper side of the paper, and let's see what happens to it. You see here, this is a paper, and if I blow air, let's see what happens to it. See here, we are blowing air on the upside. Whenever I blow air this side, the pressure at this point decreases, and the pressure in the lower portion of the page is more than the pressure at the upside. That's why the paper goes up, and in this way we can explain Bernoulli's principle. Right? Again, let us try once again. Right? Whenever we blow air on this side, the pressure at this point decreases, and the pressure at this point is more than this pressure than this one. That's why the paper from this position moves upward, and this way the principle of Bernoulli's principle working. Whenever we blow air here, the pressure at this region decreases, and the pressure at this point is more. That's why the paper blows upward. And this is how the Bernoulli's principle works. Here also you see the balloon also. Let us demonstrate once again. You see here, whenever we blow air in this position, the pressure at this point will decrease, and the pressure at this point or the pressure at this point is more than the pressure at this point. That's why the two balloons collide each other. Let us demonstrate once again. Let us blow air between the balloons. Now we have seen how the Bernoulli's principle is working in this way. Now I will give you some other examples also to show how Bernoulli's principle works. Now let us give another demonstration to show how this Bernoulli's principle is working. You see here, we have taken a colored water and a straw here, and if we blow this straw in this position, let us see what happens. Right? Let us see. Here you see that we have taken a paper, right? And let's see what happens. What we will do, we will blow air through this straw, and let's see what happens to it. Now you see how in this case also the Bernoulli's principle works. Whenever we blow air in this straw, let's see what happens. You see how this water comes out of the container and it works like a spray. And this is also the example of Bernoulli's principle. Right? Let us try once again. Let us blow this once again through this straw and let's see what happens. You see, it works like a spray or atomizer, and we also know that atomizer works on the principle of Bernoulli's principle. Let us try it once again. Here you see, this is our straw, and if you blow straw here, you see this colored water will rise here and works like a atomizer, or what we call it as spray. See how the water comes out through the container and sprays on the paper. What happens in this case, you see, whenever you blow air, you see here, whenever we are blowing air at this position, the pressure at this position has decreased, and we know that the pressure goes from higher pressure to lower pressure. The pressure is decreased here, and at that point the pressure is more. That's why the liquid rises up this straw and works as a spray. And we also know that Bernoulli's principle works on the principle, all the atomizer, not only the atomizer, but the spray works on the principle of Bernoulli's theorem. Right? These are the different methods we have shown you how Bernoulli's principle works. Right? And I will show you another experiment. You see how the Bernoulli's principle is working in that case also. Right? Let us see another example of Bernoulli's principle. Now friends, we are giving you another demonstration to show how this Bernoulli's principle is working here. You see here, we have taken a bottle, and you see here how it works. It is working on the same principle I have shown you in the previous demonstration. Whenever we press this one, there is a low pressure zone, creation of low pressure zone at this point. That's why the liquid flows through this pipe, goes up, and it works like a spray. All the spray and atomizer works on the principle of Bernoulli's theorem. Right? Let us see whether it is working or not. Here you see, we have taken a white paper to show whether it is working or not. We have taken colored water in this bottle, and let's see whether it is working or not. Now we see that this works as a sprayer, or what we call it as atomizer, and all this works on the principle of Bernoulli's theorem. Right? Here you see, we have used here Bernoulli's theorem, and this sprayer is working like that. You see here, if we spray on the hand, you see here. All the sprayer and atomizer works on the principle of Bernoulli's theorem. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.